Yes, we are Harman. We are working on the NTG5 project. This is the advanced head unit, next telematic generation, version 5, for Mercedes-Benz cars. And as my colleague present you the speakers today, we will tell you a little bit about our experience with using mobile inside car. I hope that plenty of functionalities will be new for you, and you will find many interesting things in this presentation. We'll say about Bluetooth. Bluetooth is quite obvious functionality for the mobile in the car. However, you will see how many possibilities of Bluetooth connections you will have just using your mobile. Then we'll tell you something about companion apps. I don't know if you already met with the companion apps or used the companion apps in your cars. Then we will say a few words about the new application. However, we cannot say nothing about the context because this will be released soon, but not yet released. So for now, we can just say that this is real-time CAN data application. Then a few words about safety and about the whole concept of the connected car. So how the car can make the driving more safe and I believe more pleasant. At the beginning, I want to introduce you Krzysztof Sasiak. He's our architect for the Bluetooth and telephony, and he will tell you a few words about the Bluetooth.
Hello, so my name is Krzysztof. I am responsible for Bluetooth and telephony, and in the NTG5 project we make for Daimler. So first, maybe a short intro to Bluetooth. Its features and advantages is that it uses the 2.4 gigahertz frequency, which is a technical frequency used, which is free in many countries around the world. Also used by many other devices. Also profiles like Wi-Fi. It's low energy, so it's fit for mobile phones. It's nowadays widely available, and also the technology is very cheap. So here's a schematic of how it's divided into different layers. The lower part is the part is the chip which is responsible only for Bluetooth communication. So it's the physical layer, so radio and baseband, and then there's the host controller interface, which is responsible for talking to a processor which is on the other side of the client hardware. So host control interface from the chip, Bluetooth chip, talks to a host control interface in the processor of the target device, and that's how they communicate. Above it, there's a L2 cap, and application protocols. So the link manager profile is responsible for establishing the connections for.
I will use this microphone.
Okay. For establishing the connections, authentication, pairing, and the L2 cap, which is the logical link, control, and adaptation protocol, is responsible for segmentation of the packets, for merging them back together, for multiplexing them to layers above. Yep. So now I'm going to talk a little bit about profiles available via Bluetooth. So this is the one that's most popular, hands-free profile. So as you can see, it's used widely when in applications having to do something with telephony. Yes, like hands-frees, like car keys, car speakers. Then there's A2DP and AVRCP. A2DP is the advanced audio distribution profile, which is responsible for the high-quality audio in the car, like streaming music, and it's used like, for example, JBL speakers, stereo. So there's it's used solely for a very high quality sound. And there's also additional protocol which is called audio video remote control profile, which is used for controlling the flow. So rewinding, moving forward the sound, changing tracks, stuff like that. Yeah. So also there's another telephony profile which is not so much used nowadays. It's SIM access profile. As the name suggests, it's used for accessing via Bluetooth a remote SIM card and remote telephone SIM card and authenticating to that GSM network. So its advantage over a hands-free profile is that it has a hands-free profile uses antenna, GSM antenna built into the phone, and SIM access profile usually uses only the SIM card, so the antenna is built into the car, for example, and it has much better coverage because of the antenna can be much bigger. So it's good for areas where there's bad coverage. Then we have some network access protocols like PAN, Private Area Network, and dial-up networking, DUN. The second one is nowadays rarely used because it's made for modems. And Private Area Network is just a simple area network in utilizing IP protocol. You can also nowadays write emails, write messages, send text messages from your, for example, cars like Mercedes cars, and the protocol is called MAP, Message Access Profile. We also have phone book access profile. As the name suggests, it's for accessing the phone's phone book, resolving the names of incoming calls, stuff like that. And also object exchange. So this is used widely when you're sending, for example, images to your friends. So I forgot to mention a little bit about the technical details of Bluetooth. So Bluetooth is a Bluetooth connection makes something called a Piconet. So it's made of up to 7 devices. And 2.4 gigahertz frequency, it's widely used across different devices like Wi-Fi, also other. So it's also a medical frequency, I think, or engineering frequency. So it's also, there has to be a mechanism which prevents from distortions between each of these devices. So so this 2.4 gigahertz is divided into 79 channels of 1 megahertz, which is 1 megahertz wide each. And during communication, so there's only one transmission per. After one transmission, the devices change a channel to a different one, and the algorithm of changing these channels is controlled by the master's MAC address. So all the devices, so there's one master and the other devices in the Piconet are slaves, and according to the master devices MAC, there's an algorithm for hopping between channels, and that's how the devices don't interrupt each other in the communication. Yep. So back to now a little bit of problems that we have with Bluetooth. So although it's standardized, there are different implementations across phone vendors and across device vendors. So there are really many issues. Also, there are different implementation across the operating systems of the phones. So unfortunately, one of the worst ones is Lumia. So it has a strange behavior regarding, I don't know, is it some energy saving behavior because it doesn't answer to connections when the screen is blank. So it's actually not usable when you just have your phone in your pocket and you enter the car and try to when the car automatically tries to reconnect. Well, unfortunately, it's not able to because of the I don't know, low energy settings in the Lumia phones. Also, So according to the standard, the phone should reply to paging in about 3 seconds. So it doesn't happen never. So also iPhone has strange behavior, strange. It does the RFCOM credits malversations. So the RFCOM credits is that like during communication is the number of transmissions you can make. So when there's no credits, then you cannot reply or do anything. So we have noticed like iPhone has strange behavior that some of the credits are lost when the number is really low. Then the phones just stop. The phone and our device stops communicating, and they just disconnect. Also, old Nokia phones, for example, Symbian 3.1. So when trying to connect hands-free profile, the phone, when we connect from our device from the NG5, the Nokia phone, the hands-free profile, then it also tries the phone to request us to connect A to DB profile, and when we don't allow it, then communication stops. So really many problems. We have to make many workarounds for those phones to work. Yeah, and out of work. And example use cases. So Mercedes S-Class, for example, which is downstairs. You can take a look at the car. So these are examples regarding the telephony and Bluetooth. So now when you have imagine you have only one device, then you can handle multiple calls. You have to handle multiple calls, conference calls. Then when you add that, you can have two devices. You can connect two phones because there's a separate device for the driver and a separate device for the VIP in the back. So we have to multiply it by 2. The driver and the VIP can transfer calls to each other. Also, the phones can be dual SIM. Also, the audio in the telephone can be routed from handset to hands-free and back. So there's really many use cases and many complications in making the connections and making it work with the in the car. Also. Some of the devices support multi-point connections, so you can, for example, connect two phones to a head unit in the car. So it's really complicated. Hence the squid. Yep. So that's all from my side. Thanks.
Okay. So as a mobile developers, probably you already meet Bluetooth and see that okay, this is easy. We can just connect and use it. But as you can see from the other point of view, it's not so easy, and there are plenty of use cases that should be taken into account, and audio routing should be done correctly. Okay, the second thing that we want to talk about is the companion apps. So these are the apps that you can download from the Google Play or iOS market and use it for plenty of functionalities. First thing is basic info about the car. So you can check the fuel, you can check the pressure in your tires, oil, and everything just on your handset. Even not inside the car, you can do it manually from your home, for example, before driving. You can plan the route on your phone, so you don't have to sit in the car and then choose on the screen where you want to go. You can do it just drinking your coffee comfortably in home, put in your mobile, and then automatically synchronize when you sit down in the car. What is really interesting here also is last mile navigation. So the exactly opposite one. So you are finding the parking place with Mercedes-Benz apps. You will be informed on the free parking spaces nearby. So you can. Okay, sorry. You can find the parking place, yes, and then after getting out of the car, you will have either on your watch or your mobile the last mile navigation information. So you will be directed exactly to the meeting place, not just to the parking place. Yes, and this is done automatically. You can do it without any actions. You can use your mobile as your car key, so you don't have to carry on additional keys, and so this is done via NFC. It is safe, believe me, this is safe. It's not like, yes? Yes, this is software key. This is software key, and this is not only on a mobile. This is also connected with the service. The automatic parking is something letting you to park your car in the parking lot that you have almost no space for you to get out. You can just sit out of car and use your mobile to remotely drive your car. It's not allowed to make the fast speeds, so it's not like remote car using the mobile. Then you cannot have, for example, S-Class like remote RC car. No, it's not like that. This is using the parking assistance, and you can make this make the drive into the parking lot with assistance of the parking assistance on your mobile. There is a safety feature that is requiring to make all the moves on the mobile. So you have to keep moving your finger on the mobile, then the car is moving. If you stop, it stops. So this is something that prevents, for example, crashing some children. If you see somebody on the road, you can just put your finger up from your phone. It's stopped, so it's safe. And so basically these are the basic concepts about the companion app. Now Mariusz will tell you something more about how the communication is done and what is the parsing of the messages on the head unit.
Hi guys, I am Mariusz Kaźmierczak. I'm working on the I'm working on the integration of one of our companion apps, which uses Bluetooth communication with head unit. And now I will try to. Okay, here is a very high-level picture how the communication between the application and car's head unit looks like. I will show you this picture a few times because I will go to the next slides, but I will back to this. So the first step in order to have anything working is to have working communication between the mobile and head unit, and as I said, it's done over Bluetooth. We have also applications which uses Wi-Fi network, and Łukasz will talk about that. So in order to connect the mobile application with the head unit, we use one of the Bluetooth profiles, which is SPP. So this is a serial port profile. It defines how to set up a virtual serial port connection over the Bluetooth. So it's similar to cable RS232 connection. It's based on the RFCON protocol, and the max payload for this profile is 128 bytes. And on the next slide, you will see how the stack for this profile looks like. So we have some underlying profiles which must be implemented in order to use SPP. Krzysiek already mentioned about maybe not all of them, but just to remind, baseband is used with the lower level protocol. It defines the operation at bit level and package level. After that, we have a link manager profile. So it's responsible for establishing the connection, releasing the connection, traffic, scheduling, authentication, and so on. We have SDP, which is service discovery profile. This profile actually is used to get the knowledge about what profiles are supported by the device. For example, when we want to connect our mobile to the headphone, then using this profile, we can check what the Bluetooth profiles are supported by the device which want to connect. And there is also a RFCOM. This is a radio frequency communication. In the Bluetooth, it is widely used because it's rather simple to implement. It also has a widespread support. API for this is, I think, available almost for all the platforms. And okay, above we have some specific API for the Bluetooth handling, which application may use, and it depends on the operating system we are using. Yes. Okay, so what should be done in order to get the connection over SPP? First, we should establish link and set up virtual serial connection. That means that first we should submit a query to SDP to get some details about RFCOM server we want to use. After that, optional thing is that we may specify if the authorization is required or not. Next step is to get the channel from L to CAP interface. After that, when we have the channel, we should initialize session. And the last step is to establish a link connection. And when it's done, then the second device just should authorize if it was required and accept all the things. Okay, so these are the steps which should be done to have SPP profile working. How it looks on our project. We have some service defined, and when we connect first HFP device to the head unit, we are registering this service. And now, when the application starts the one of the companion app, it's just send the request to connect to use this service. So on our side, we are in the kernel space create a character device which is used to communicate, and it's handled normally as a regular file from the user space. So we just open the file in read-write binary mode, and we can exchange the messages between the mobile application and between the and head unit. So if we already have a communication, then it is possible to send the XML request from the mobile to the head unit. We are able to read this request, and now we must do something with the information which is provided with this XML, because XML itself isn't readable on the head unit side. So the next step is to parse the provided request in order to get all the information which is later used to, for example, as you can see on the slide, call specific CAN interfaces to get required information. To parse the messages, we use XML Parser. It's written in C. It was one of the first XML parsers with open source code, so it's used by many of Mozilla projects. It's used by, for example, Perl XML parser. It's a streaming-oriented parser. It provides good performance, reliability, and correctness. On the xml.com site, you may find some benchmark where few XML parsers are compared, and the XPath is the fastest one. Really close to this parser is XRP, and far further for these two parsers are, for example, XML for J and Perl parsers and Python parsers. Okay, so this parsers provides really huge amount of functionality, but in order to use it, at least for our needs, is just to use the listed methods. So first we should create the parser. After that we should set user data, because the first argument to the most of the parser functions is the pointer to the structure which with user data, and this is actually the only way to exchange the information between the functions which are used by the parser. After that, we should set some handlers for example, for start element and end element. We can also set encoding and so on. So how it works? Basically, the XML is processed as just a stream of bytes, so we don't need to have all the XML in order to start processing. We just may have some part of it, and start and end handlers are just called when some tokens occur in the XML. And okay, it seems that it's similar to the SACS, but it isn't. XPath doesn't. Okay, it doesn't support all the requirements which SACS should support, but it's used as a base for the SACS parsers and DOM parsers. So, guys, showing me that the time is over. So now I will ask Łukasz.
Okay. Hello, my name is Łukasz. I was involved in development of the application of. I was involved on the Harman side to prepare changes on the head unit side in order to support the application that Daimler is going to release in the near future. And of course, this application is not released yet, so I cannot share with you more details about the application itself. However, I can tell you about the main concept and main requirements which we had to support on the head unit side in order to meet the requirements that application the requirement were set. Okay. So generally, the main requirements were to reuse and extend the authorization protocol that is currently in use for the companion application. And we had also to extend the XML parsers because during the authorization process and further when the mobile application we're going to send a request to the head unit. Then new XML tags were introduced and new XML attributes were introduced, and we had to extend the XML parser. Okay, you can see here a brief comparison VLAN versus Bluetooth. And indeed, for example, the range for VLAN and Bluetooth is fine to establish connection and keep it alive when we, for example, will drive a car. From the other hand, the Bluetooth advantage is that power consumption is lower than in case of Wi-Fi. And from the other hand, latency of the Wi-Fi is lower and bitrate is higher, which was really important from our point of view, because we wanted the data which we're going to send from the head unit to the application. We wanted to have a lowest possible latency. Okay, and before I will talk about the implementation that we did on the head unit side for the application, I would like to briefly introduce to the CAN. CAN is an abbreviation from Controller Area Network. And it is an asynchronous bus. It is a bus vehicle standard that is used generally to connect all the microcontrollers in the car and devices. And it is widely used by car manufacturers. And CAN allows to immediately transmit the data from one node to another, and all other CAN nodes receive the data in the same time. So it is only a matter for CAN nodes to filter which messages they want to receive. And some kind of interesting properties are that introducing a CAN network significantly reduce the weight of the wires and length of the wires needed in the car to connect all the sensors that have to communicate between each other. And it was done because that CAN node use a single interface to communicate with other CAN nodes. And okay, and it was possible to reduce the number of the wires because car manufacturers don't need to make a wire connection between every node in the car that require to exchange the information. So generally, the CAN bus, using CAN bus benefits are following. They are low cost. They are used only 2 wires with good performance and ratio, and because the CAN devices are very widely used and produced in high volume by the car manufacturers, they are cheap. CAN is reliable. There is a sophisticated error management detection, and in case occurring the error, the message is going to be retransmitted. and all nodes are informed about the error faults. And additionally, the CAN is real time. It means that at the distance of 40 meters of wire, the data throughput is about 1 megabit per second. So it allows for quite immediate receiving the data from the different nodes in the car, from the different sensors. And CAN is flexible. It means that it doesn't force to any software changes or hardware changes when you would like to connect a new node to the CAN network. And CAN is also standardized. The first standard ISO 11898 is the most widely used standard. It offers data throughput from 40 kilobits per second to 1 megabit per second. And going further, we have here the slide in which you can see the CAN and navigation data management that was implemented by us in order to send those data to the application. So generally, as I told you before, the CAN is responsible. The CAN here component is responsible to gather all the data from the car, from the sensors in the car, and send it to our application component. The application component is what actually we implemented for the application in the head unit. In fact, the navigation and CAN, they are interfaces to other components. We just use the interfaces to register for specific data in navigation and CAN. And application components collect all the data and sends every 100 milliseconds to VLAN component, which further sends this data to the application. VLAN component is responsible for communication between application and head unit. So in application component, we additionally have to average the data or send the latest data, because we send the data, we trigger sending the data every 100 milliseconds. However, we are receiving much more often the updates from CAN and navigation. And for example, we can within 100 milliseconds receive 10 updates about the vehicle speed. And we have to send, for example, the average value to the application. And going further, the application in the phone, which is connected, which is establishing a connection with our VLAN component. In the first phase, it has to be authorized. So it sends a couple of requests that are used to validate and check whether we support this application and the application can be connected. And if yes, then application, if application was authorized, then application sends in the further stage, it sends generally two types of requests. It is subscribe and unsubscribe for receiving the data. It is subscribe because it is by sending a subscribe request, the data from the CAN and navigation is enabled for sending, they are enabled and the updates are sent. So generally the application components works is idle if the request doesn't came in, because otherwise there would be unnecessary consumption of the resources in the head unit if it had to process all the count data and navigation data while the application wouldn't receive the updates and it wouldn't be needed by application. Going further, I will tell you about two interesting problems that we met during the development of the changes on the head unit side. First was that when we did an extension of the authorization protocol for the phone application, the authorization was work, and we thought that it was finished and worked fine. However, the application was tested by Daimler security team, and it occurs that when they raised a defect for us, in which the head unit was crashing, and it was a serious problem. We noticed that they implemented its own application, which was simulating the application that will be working on the phone. So they did an authorization. Authorization went successfully, but when authorization went successfully, they were starting to sending fuzzy messages and messages dedicated for the companion app. And while the fuzzy messages were simply ignored, the companion app messages were not. And this caused that head unit went to the path in the source code that was not reachable, and we didn't think that it can go there. So, of course, we had to fix this bug and also ignore the requests that were dedicated only for the companion app. And the second issue that was quite interesting was that also at development stage we were testing concurrent connection of the companion app and this application that will be soon released. Well, it occurred that when the application went into background on the iPhone, it seems that iOS suspended the application. So we noticed that on the head unit side, that connection was still established. We didn't receive any change, any update, and head unit was trying to send constantly the messages to the application, while application was not receiving those updates because it simply was suspended. And because of that, we had to simply make an agreement with Daimler developers, which were responsible for developing an application that that when application will going to be suspended, they should send us some kind of request to unsubscribe, and in that moment head unit will stop collecting the data and sending this data to the application. Okay, that's all. Sorry for that.
Okay, so just a few words to finish this presentation. As you can see, all these applications are connected to your phone that can be hacked. Believe me, it can be. And you don't want your car to be hacked because it can make your big problems with your safety and even, you know, your life. So basically, to prevent that situation, we have several tests performed on each release. As you can see, I will not now read all of this because we are running out of time. However, on each stage, the release can be just dropped and say that we have to fix something. Yes, so the stages of the tests are quite challenging. What is more, as Łukasz said, we have special team in Daimler that is the specialized security team that is trying to hack our applications. So They are not only checking if the application is running due to the specification, but they are trying to get in some other ways. Unfortunately, I don't know why the movie is not working. This is the Tesla case. If you haven't seen that movie yet, please browse the Tesla hacking. There is the security team in China that took Tesla car and showed that it's possible to open the car top, open the luggage, and even brake. So even use the brakes and steering wheel from remote. Yes. So they present that the guy was sitting in the office 16 kilometers from the test drive, and just the guy inside the car called him and say, "Okay, please brake my car," and he did that. This is pretty frightening. This was released after the fix was done. So of course the Tesla cars are now probably safe, but you never know. Yes. That's why in our project we implemented so many layers of safety tests to prevent that situation. And just a few words about the connected car. So you don't have to connect your own mobile to the car to be connected to the network. In Mercedes cars, you can find the Hermes device that is actually the Android-driven modem. It can help you with advanced telematics and failure prediction. So the car will tell you when it will brake before it will brake. It's done on the big data, it's done on the statistics. So you will have the information that something went wrong before it will happen. So the safety is much more improved in this case. And if something will happen, of course, this is not, this shouldn't be often, but sometimes you can have emergency situation. There's the functionality called emergency call. And basically when the car crash to some other car, some tree, whatever, the car automatically detects that based on the airbags, based on the speeds and the accelerations, and automatically is calling the emergency services, giving them your position, giving them all the information from the car, what was the current status of the car, where you are, and how many people probably, of course, how many people probably need to be secured. So this is something that can save your lives. Of course, in Poland, it can really happen that even if you have the accident, somebody is nearby, but please imagine the States or Australia where you can just drive on some road for 1,000 kilometers and you can meet nobody. So this is really useful, and yeah, it can save a life. Okay, so sorry for being not time really compliant, but if you have any questions now, we'll be happy to answer all your questions.
So basically my question is you are working with Daimler Mercedes API, yes? Is it a public API that everyone has access to and I can just go home and write a companion app for my car or not? Okay.
No. So this is something that is done only by the developers on the specification that is confidential, and of course you can try to hack it somehow, but the specification is closed, so you cannot write this application by yourself. Of course, you can just be hired by Daimler, so it's...
Another question, in your daily work, do you work with some head unit simulators, or do you have a part of the head unit just in the office and communicate with this?
Okay, so basically each of us have on our desk the head unit with all components needed to the work. So if we are working on the Hermes device, we have, believe me, a lot of equipment to do that, because we have head unit plus Hermes plus all the screens plus Canoe to send the signals and simulate the cars. This is the first layer. We also have the simulators, but it's mainly for the HMI stuff. And in fact, the last test is always done in the car. So this is something that should be done in the car, and you cannot simulate everything from the car.
Another thing, all those tests that you mentioned were created by you, or are they part of the SDK or SDK that is delivered by Mercedes? They gave you the unit tests or the functional tests for the app, or did you create them on your own?
Okay, so maybe I'll scroll to the tests. So there are plenty of there are plenty of layers. So basically, Some tests are performed even by developers during the development. I don't know why. Okay, so basically the first tests are performed by developers. Then our testers come to the action, and then first they perform sanity tests that are done before even submitting the code to the perforce. Then after each build, we have daily release and system tests. Yes, these are also done by us. Security tests and drive tests are defined by Daimler, and qualification drive tests are the external company hired by Daimler.
And the last thing that I would like to know, what about Bluetooth communication? I understand that the Bluetooth server is on the head unit, and basically, what about if you have a constant connection, what about power saving on the device? Do you take care about this and think about this?
So the Bluetooth standard has this already built in, so it takes care of not sending unnecessary messages into the air unless there is a need for that. So it's already in the standard. I don't remember the technologies exactly, but yeah, it's there.
I also work with Bluetooth in our app, but do you have any issues with Bluetooth stack implementation between iOS and Android?
Yes, I should already mentioned that there are some very annoying like implementations inside iPhone, especially. Also, Samsung phones sometimes are really buggy. Yeah, so there are some.
So thank you.